Hey everyone, welcome back to yet another video on GenAI Vlog. So in this video, we're going to be talking about how to use weights and biases to train the embedding layer on distilled Roberta model. It is a large language model, but in this case, we just want to train the embedding layer. And then we're going to push the model onto HuggingFace. So this is the collab that I've been using for this video. First of all, I want to acknowledge that full credits goes to this person. Manu, if you're watching the video, I just want to let you know that me personally, I very much appreciate the contribution you made for the GenAI community. So with that being said, just want to shout out to this person. He provided a script. I'm just running some tests. So first things first, you want to check the NVIDIA, make sure that's set up. Here I used T4 NVIDIA, but that's the setup on Colab. And then you want to install the packages. The one I found interesting is Accelerate as well as Weights and Bias or WANGDB. First things first, you want to import a couple of libraries, set up your model name, distilled Roberta, and we're going to use a base model. And then we're going to save some path, and that's the path that you want to save as output. You acquired model first by using sentence transformer. That's the library that's coming from HuggingFace. So this is what the data looks like. Let's load that up in a notebook. Once you load it up, you can see that there's an anchor, there's a positive, there's a negative. The anchor is a sentence. A person on a horse jumps over a broken down airplane. The positive says a person is outdoors on a horse, whereas the negative says a person is at a diner ordering an omelet. As you can see, obviously, the positive cases is very similar to the situation in the anchor, whereas in the negative probably doesn't have anything to do with the anchor. So that is a setup. And then from here, we're going to set up our loss function. We're going to keep track of evaluation loss, so on and so forth. Don't worry about the code here. I'm going to show you a graphical visualization, how these things look. And then you're going to set up your training arguments. So after that's done, you can create a trainer using this code sentence transformer trainer, and then you can go ahead and start training. Now, this actually requires you to have a weights and bias or WANGDB API key. So this is the weightsandbias.ai website. You can sign up account and get your API key from here. And with that being said, let's go back to the training process. Once you execute this line of code, you can see the training starts to happen. And then it actually documents the records of the loss, the epoch, things like that. So before I continue, let me just show you guys a little bit of what the training process look like. Here's the training process on weights and bias. Now, I really enjoy this visualization because as you see the steps going up in training epoch, you can actually see the loss going down. That makes sense. And then once you get to the itty bitty region in the loss function, you actually lower your learning rate. And so that also makes sense. And then if you scroll down here, it actually show you a full scale of your GPU usage. And I found it really interesting that in the middle, GPU temperature actually hype up to when it's about 120 seconds and then eventually die down. So I thought something like that's interesting. Maybe that affects the load balance. If you scale this up to multiple GPUs, perhaps it also needs to go to different regions depending on where you train this thing on the cloud or wherever you are in the world. I think something like that is definitely worth our attention. And this visualization can provide that information for us. So with that being said, let's go back. Now that this is a finished training, obviously you want to evaluate the benchmark, right? So, you pick one, let's use the STS benchmark. And here's all the performance that you can test using this evaluator. Once that's done, you can save the model, and then you can use the Hugging Face token to push this on to the Hugging Face hub. So with that being said, I already did it. It's pushed onto this URL. Let me show you that real fast. And then as you see, here's a model card under my account. And the model here is distilled Roberta, and it's a base model, and the data is NLI. So with that being said, let's run some tests. Here's a quick inference API. Let me throw in an anchor sentence. Now, for example, I can say, I love large language model. And then I want to compare to two sentences, right? So that I can see which one score is higher, which one score is lower. So I'm going to write something that's similar to this. I use large language model every day. And then I'm going to give another thing that has nothing to do with it, right? For example, I love eating apple. Let's see this simple use case. Obviously, we know that's first sentence. It's similar. The second sentence probably doesn't have anything to do with the original sentence. So let's say compute. And then it's going to try to compute the similarity of these two sentences I entered, comparing with the source sentence. So once that's done, you can see that the first sentence actually 83% similarity. The second sentence, maybe not so much. It has only 45% similarity. So this is a simple use case. And then on top of that, there's a model description on the left-hand side. And then here are some code for usage. You can actually use this code in your Python environment and develop your own applications and take it from there. So there you go. Hopefully you enjoyed this video. Hopefully this video sheds some lights of how you could fine-tune the embeddings of a large language model, such as distilled Roberta, push onto some sort of cloud platform and send up some sort of API. And then you can use that to develop your own RAG algorithm or whatever other chatbots that you can develop. Because guess what? This is sentence comparison, right? If you have 2 or 3 sentences, you can compare to the original sentence, and then you can kind of get a similarity. And that could be extremely helpful if you are building Copilot, and when the Copilot needs to compare and contrast different retrieved documents from different sources based on different persona, based on different user profile, this kind of model can definitely come in handy. With that being said, thank you for watching, like and subscribe.